The test statistic of z equals negative 2.86 is obtained when testing the claim that the population proportion is not equal to 0.517. This is a two-tailed test. Using a 0.05 significance level, we're going to complete parts A and B. So the first thing we need to do is find the critical values. So let's go ahead and do that. So even though we're going to write down the given information in here, so the first thing we're going to do is we're going to state the claim and the opposite of the claim. So we know that the claim is given to be the following. We know the claim is that the population proportion is not equal to 0.517. And therefore the opposite of that claim is that the proportion is equal to 0.517. So we're going to use this information to then determine the null and the alternative hypothesis. Okay, so remember that the null hypothesis always contains the equality. So we know that the opposite has the equality, so therefore we know that P is going to equal 0.517 for the null, and therefore the alternative is that P is not going to equal 0.517. Okay, now it's already been determined it's a two-tailed test, but the reason why is because the alternative hypothesis has a not equals, and that's why it's a two-tailed test. Okay, so now we need to also write down what the significance level is, which is alpha, and it's given to be 0.05. So alpha is equal to 0.05. And then we'd also been given the test statistic, and so z is going to equal negative 2.86. Okay, so now we're going to draw our curve and then label and then find the critical values. So the first thing we need to determine is we know it's a two-tail, and since it's two-tail, that means that when we take alpha, which is the significance level of 0.05, we need to take that and divide it by 2 since it's a two-tail. So when we divide it by 2, we get 0.025. And then we're going to determine that we're going to have two critical values. Okay, so in order to do that, we're going to draw our bell curve. We know that we have a mean of 0, and we're going to have two critical values. We're going to have a negative critical value, and then we're going to have a positive critical value. And we know that the area on the left here is 0.025, and then the area here is going to be 0.025. And therefore this is going to represent the critical region. And this is also going to represent the critical region. So in order to find the critical values, okay, we're going to use StatCrunch. So we're looking for the probability of this negative value, where it's going to be less than or equal to what that critical value is going to give us an area of 0.025. And then the other critical value is going to be greater than or equal to what that critical value is, and that's going to give us 0.025 as well. So let's determine the critical values using StatCrunch. Okay, we're going to go to Stat, Calculators, and then scroll all the way down to Normal, since our test statistic is a Z test statistic. And so now what we're going to do is the following. We're going to put in less than or equal to, and then we're going to put in our area of 0.025 in the left tail, and we get negative 1.96. So negative 1.96 represents our critical value here, so that's the first critical value. Okay, and then if we erase that and make this greater than or equal to with the area to the right of 0.025, we get the positive version, which is 1.96. So that's positive 1.96. So therefore, that is the other critical value. So let's go ahead and put our answers in. So we know that there's two critical values. The lower one is negative 1.96, and the upper critical value is positive 1.96. Check our answer, and there is our result. Okay, now we need to determine, should we reject the null hypothesis or should we fail to reject the null hypothesis? And in order to do that, we need to look at the test statistic. So we know that the test statistic, okay, is given to be z, which is equal to negative 2.86. Okay, so the test statistic, again, is z, which is equal to negative 2.86. And so negative 2.86 is to the left of negative 1.96. So that means that we would reject the null hypothesis if the test statistic is in the critical region. And the test statistic is in the critical region. So we would say that the test statistic, negative 2.86, is in the critical region. And therefore, since it's in the critical region, we would say the following. We would say that the null hypothesis should be rejected since the test statistic is in the critical region. So we would say the null hypothesis should be rejected since the test statistic is in the critical region. Checking our answer, and there is our result.